In the previous unit, we introduced the basic concepts required to implement a parallel program in heap and use GPUs to run the program. We have demonstrated simple examples like vector addition and matrix multiplication. We see that it is not too hard to write basic programs with heap. However, as our program scale becomes larger, we may face new challenges and may require new language features. Therefore, in this section of heap programming, we will discuss several new concepts that are slightly more advanced to help you with more comprehensive understanding of heap programming. We start with the function type qualifiers in heap. The function type qualifier in heap is a concept in GPU programming that is used to specify the type of a function. We use the qualifiers to tell the compiler if the function is to be executed on the CPU, the GPU, or both. Functions are created by early programming languages to avoid code repetition. It is a piece of code being used multiple times, and the code can be encapsulated in a function to be called as multiple places. The encapsulation provided by functions also reduces the mental burdens of programmers, as programmers do not have to remember the implementation details of the functions. They can trust the functions to provide the feature claimed by the function name. In the vector addition example we have seen earlier, we probably do not need another function to encapsulate some well-defined features. But as the scale of the GPU program grows larger in the real-world applications, we naturally want functions to reduce the complexity. But heap program is a bit complex. The compiler needs the programmer to tell the compiler if the function is a kernel, a GPU function, or a CPU function. Here we say a kernel is a function to be called by the CPU and to be executed on the GPU. A CPU or GPU functions are being called and executed on the CPU and GPU respectively. Since we assume the GPU works under the supervision of the CPU, there is no function type that is called by a GPU and executed on a CPU. To fulfill this need, heap uses function type qualifiers to provide information about the function about where to execute it. We start with the function type qualifier global. Note that there are two underscores before and after the keyword global, and the same goes for all the other function type qualifiers. So far in our previous heap programming examples, we have used only global qualifier. The global function type qualifier declares a function as a kernel, and that can be called from the host CPU and can be executed on the GPU. The function does not return values to the host CPU. The communication between the CPU and the GPU needs to be completed with the following memory copy API called. Let's look at an example of a kernel using global function. In this example, we can see the global function specifies the type of a function, including its return type void and the type of its parameters. So what if we need to call a function from this kernel? The device function type qualifier defines a function called by kernels or another GPU function, and this function is to be executed on the GPU. In heap, device functions are used to encapsulate small reusable computations that can be called from multiple GPU functions. These functions are executed on the GPU and can help to simplify and optimize GPU code by breaking it down into smaller and reusable components. Here we are using a simple example which is not much useful in terms of implementation but serves the purpose of understanding the usage of device function. In this example, in the first block, the code contains a definition of a device function getGlobalId that calculates the global index of the thread within a block of threads and returns a value. And in the second block, the myKernel function is declared with the global qualifier, which means it is a kernel function that can be executed on the GPU as a parallel computation. This myKernel function calculates the global index of the thread using the getGlobalId function and stores it in the id variable. Finally, the third block contains the main function which launches the kernel. In this way, multiple GPU functions can reuse the computation in the device function to simplify and optimize the GPU code. Other than the global and device qualifier, heap also defines the host qualifier. In heap, the host qualifier is used to indicate that a function will be executed on the CPU. This function must be called from the host. If no qualifier is specified, the function is assumed to be executed on the CPU by default. Therefore, the host qualifier is equivalent to not having any qualifier at all. In these examples shown here, the function in the first and second block operate in the same manner. Besides, the device and host function qualifiers in heap can be combined. When device qualifier is combined with host qualifier, it creates a function that is visible and executable both on the host CPU and the device GPU. When device qualifier is combined with host qualifier, it creates a function that is visible and executable both on the host CPU and the device GPU. Such functions are referred as the device and host functions. This makes them useful for code that needs to be shared between the host and the device and avoid the requirement for programming the logic twice. As we can see in the example here, the function my function can be called from both the host code and the device code and can access both host and device memory, making it convenient for sharing code between host and the device. One thing to be careful about is that since the CPU and GPU runs with different programming models, some GPU-specific data structure cannot be used in functions with both host and device qualifiers. For example, the function we demonstrated before we get global ID function cannot also have the host qualifier. This restriction ensures the program executes correctly. On the other hand, it is impossible to combine device function with global function because the global qualifier is used to specify a kernel function that will run on the device in parallel. But device qualifier is used to specify a function that is executable only on the device as one thread. Combining these two qualifiers in the same function declaration can lead to confusion about the intended behavior and execution target of the function. And similar to the device function, the host function cannot be combined with the global functions as well. We know that the host functions are meant to be executed only on the host and cannot be executed on the device, whereas global functions are meant to be executed on the device. Therefore, it is not possible to combine them into a single function. In the next video, we will discuss the use of template feature in heap programming.